Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Can you explain how Monte Carlo Tree Search, MCTS, helps Retrieval-Augmented Generation, RAG, models improve their retrieval effectiveness and enhance their reasoning capabilities?
Monte Carlo Tree Search, MCTS, can boost RAG models' retrieval efficiency and reasoning capabilities by leveraging its strengths in efficient exploration, handling uncertainties, and multi-step reasoning. Improved retrieval efficiency. MCTS allows the RAG model to explore a wider range of retrieval possibilities. It simulates different retrieval actions and evaluates their outcomes, helping the model identify the most relevant documents for a given task. This results in more effective retrieval, which provides a stronger foundation for subsequent text generation. Enhanced reasoning capabilities. MCTS enables the RAG model to reason over multiple steps and consider the impact of different actions on the overall outcome. This allows the model to make more informed decisions, especially when dealing with complex or uncertain situations. MCTS helps the model navigate the graph of thoughts and actions, selecting the most promising paths to follow. Handling uncertainties. MCTS incorporates randomized simulations and statistical evaluations, which help the RAG model handle uncertainties in the retrieval and generation processes. It balances exploration, trying new options, and exploitation, leveraging successful strategies to find the best balance between exploring new possibilities and sticking to proven approaches.
Can you provide a specific example of how MCTS is used to enhance the multi-step reasoning capabilities of RAG models? Example of enhanced multi-step reasoning. Consider a RAG model tasked with generating a summary of a study. Using MCTS, the model starts by retrieving a set of relevant documents. Then, it simulates different sequences of actions, such as selecting specific sentences from different documents, ordering them, and generating connecting text. At each step, MCTS evaluates the potential outcomes of different actions. It simulates multiple playthroughs of the reasoning process, considering the impact of each action on the overall coherence, relevance, and quality of the generated summary. Based on these simulations, MCTS guides the RAG model towards the most promising paths, helping it make informed decisions and generate a coherent and informative summary that effectively captures the key points and insights from the retrieved documents.
Sure. Here is a specific example of how MCTS can improve the multi-step reasoning performance of RAG models. Consider a RAG model that is tasked with answering a complex question that requires reasoning over multiple steps. For instance, the question could be, what is the capital of France, and what is the population of Paris? To answer this question, the RAG model would need to perform the following steps. 1. Retrieve relevant documents from its knowledge base that contain information about France and Paris. 2. Extract the capital of France from the retrieved documents. 3. Find the population of Paris in the retrieved documents. 4. Generate a coherent and informative answer that combines the extracted information. Traditional RAG models typically handle each of these steps independently, which can lead to errors or inconsistencies in the final answer. For example, the model might retrieve irrelevant documents or fail to extract the correct information from the retrieved documents. MCTS can help to improve the multi-step reasoning performance of RAG models by allowing them to explore and evaluate different sequences of actions. In the example above, MCTS could consider multiple different ways to retrieve documents, extract information, and generate an answer. By simulating and evaluating these different sequences, MCTS can identify the most promising path and guide the RAG model towards a more accurate and consistent answer. In this specific example, MCTS could help the RAG model to identify the most relevant documents to retrieve for the given question, extract the capital of France and the population of Paris accurately from the retrieved documents, generate an answer that is coherent and informative, combining the extracted information in a meaningful way. By incorporating MCTS into the RAG model, we can significantly improve its ability to handle multi-step reasoning tasks. leading to more accurate and consistent answers.
Can you explain how MEX addresses the challenge of handling uncertainties in retrieval-augmented generation and what benefits it brings to RAG models? Handling uncertainties in retrieval-augmented generation. MEX addresses the challenge of handling uncertainties in retrieval-augmented generation by incorporating randomized simulations and statistical evaluations into the decision-making process. Here's how it works. Exploration versus exploitation. MEX balances exploration, trying new options, and exploitation, leveraging successful strategies to navigate the uncertainty in the retrieval and generation process. It explores different possibilities, evaluates their outcomes, and learns from them to make informed decisions. Uncertainty quantification. MEX quantifies the uncertainty associated with different actions and outcomes. It estimates the probability of success for each action and uses this information to guide its decision-making. This helps the RAG model avoid getting stuck in local optima and explore promising but uncertain paths. Benefits of MEX for RAG models. Improved robustness. MEX enhances the robustness of RAG models by enabling them to handle noisy or incomplete information in the knowledge base. It can explore alternative retrieval and generation strategies, increasing the chances of finding a satisfactory solution even in uncertain situations. Better generalization. By incorporating uncertainty handling, MEX helps RAG models generalize better to new and unseen data. It learns to adapt its behavior based on the level of uncertainty, making it more flexible and applicable to a wider range of tasks. Increased confidence. MEX provides RAG models with a measure of confidence in their predictions. The model can estimate the uncertainty of its outputs, allowing it to make more reliable decisions and avoid overconfidence.
MEX enhances RAG systems by robustly addressing uncertainties in the retrieval and generation processes. It allows the system to handle incomplete or irrelevant information during retrieval and inconsistencies or factual errors during generation. MEX achieves this by simulating multiple potential outcomes and evaluating them statistically. It considers the uncertainties in both retrieval and generation, guiding RAG systems towards more reliable and consistent generations. This robustness enables RAG systems to perform effectively, even with noisy or incomplete information.
Can you provide a specific example to illustrate how MEX enhances the multi-step reasoning capabilities of RAG models in handling complex questions?
MEX enhances the multi-step reasoning capabilities of RAG models by simulating and evaluating sequences of retrieval and generation actions. This is particularly useful for real-world tasks that involve iterative retrieval, conditioning, and generation processes. For example, in a question-answering scenario, the RAG model may need to retrieve relevant information, generate a partial answer, retrieve additional context, and then refine the final answer. MEX can facilitate this multi-step reasoning by exploring and evaluating different sequences of actions. Imagine a scenario where you need to plan a trip from your home to a distant city. You would typically start by retrieving information about potential destinations such as their attractions and costs. Then, you might generate a rough itinerary based on the information you have gathered. Next, you might retrieve additional information about specific activities or accommodations and refine your itinerary accordingly. This process involves multiple steps of retrieval, conditioning, and generation. And MEX can help you find the optimal path through this multi-step reasoning process.
Can you provide a specific example to illustrate how MEX enhances the multi-step reasoning capabilities of RAG models in handling complex questions?